Thanks for listening to this Institute of Art and Ideas podcast, bringing you philosophy for our times. Here at the IAI, we're committed to taking philosophy out of dusty books and lecture halls and into the heart of public life. If you enjoy this debate and want to carry on the discussion, or watch over 1,000 more debates and talks on all the latest issues in philosophy, science, politics and arts, visit iai.tv. Remember to subscribe and review on iTunes.
Good afternoon, welcome. I see the standing room only. They've even put more chairs in. This is how, hopefully, we're going to get to the end of whether there are natural laws or not by the end of this debate. So it's a historic moment. This debate is about whether there are laws or not of the universe, or whether we think there are. So from Newton's laws to E = mc squared and beyond, we think we've uncovered the secrets of the universe. But some people claim that these laws evolve, and others point to their human and cultural origins. So are eternal laws just a bit of human hubris, or are we seeing the mind of God? The three panellists we've got are expressed a range of views on this issue. On my right is Rupert Sheldrake. He's a biologist best known for his hypothesis of morphic resonance and his research on telepathy in dogs and in people. On my left is CERN physicist John Ellis, who coined the term theory of everything and co-authored the first paper on how to find the Higgs boson back in 1976. And then on my far left is Nancy Cartwright, a former mathematician and a philosopher of science. Nancy's book, How the Laws of Physics Lie, has provoked continuing and internationally cited debate. So, you know the format of the debates already, but I'll tell you. We're going to give the speakers 4 minutes each to give their pitches, and then we'll go through 3 themes in the debate afterwards, and then we'll go over to you for questions. So first to speak will be Rupert.
Well, in the 17th century, as modern science got going, most of the founders of modern science, the physicists who were part of that revolution, were Christians who believed that the God who ruled this universe was a kind of mathematically minded God, and that the laws of nature were like Platonic ideas in the minds of God. Science, therefore, could find out something about the mind of God by understanding the laws of nature. In the 18th century, the Enlightenment, which had Newton as a kind of demigod, saw him as somebody who'd revealed something about the true nature of the divine. So this was really based on a kind of Platonic theology. In the 20th century, with the Big Bang revolution in cosmology, we have an evolutionary view of the entire cosmos. But most physicists clung on to the idea of eternal laws. That's the way they were used to thinking, and many mathematicians are at least secret Platonists. They don't usually come out in public saying it because they know it would be identified as a metaphysical position. But nevertheless, it underlies a lot of what's going on. And this access to the laws of nature, the fundamental principles of nature by physicists through mathematics, is, of course, part of the reason why physics has such a high prestige in the pecking order of science. Biologists, by contrast, are dealing with completely provincial affairs like life on one insignificant planet in the outskirts of one particular galaxy, whereas physicists are dealing with the true universal principles of all nature, of everything indeed. So the question that the evolutionary cosmology raises is, couldn't the laws of nature evolve as well? And as soon as you ask that question, you begin to wonder about the concept of laws of nature. In the 17th century, completely anthropocentric metaphor. God was like a cosmic emperor. He made up the laws of nature, and he was also, through being omnipotent, the universal law enforcement agency that made sure that everything obeyed them. Not really appropriate in today's climate. And in an evolutionary universe, a number of philosophers and scientists have raised the possibility that the laws actually might be more like habits. I think so myself. The philosopher C.S. Peirce suggested this at the beginning of the 20th century. The current cosmologist Lee Smolin is advocating a similar view. And that would suggest that instead of the whole universe being fixed from the outset, there's a kind of memory within nature. What happens depends on what's happened before, and these habits will evolve through a kind of cosmic natural selection. For example, On the eternal law view, if you consider the forms of crystals, you make a new chemical compound never made before, and you crystallize it. According to the eternal law view, the way it crystallizes should be completely predictable because the laws of electromagnetism, thermodynamics, etc., have always been there and they're always the same. By contrast, on the habit view, the first time it crystallizes, a new habit has to come into being. You may have to wait a long time for a new crystal lattice structure to appear. After you've done it once, it should get easier to crystallize everywhere else. The more often you do it, the easier it should get to crystallize. And as the habit gets stronger, the melting point might go up as well because it would become more stable. The evidence suggests compounds do get easier to crystallize, and I've been doing research on the history of melting points. There's a general rise in melting points. The empirical tests, in my view, suggest this is what's going on. There are many other tests of this habit principle in nature. And I think finally, my final point is this. The idea that the universe is governed by eternal laws and fixed constants, or maybe slightly variable constants, has given rise to a proliferation of speculation among cosmologists. The idea that if they're just the way they are, then either there has to be some kind of fine-tuning, deistic type deity, fine-tuning them so they're just right for us to be here, or there have to be billions of unobserved universes which have different laws, and we just happen to be in the one that's right for us. Many cosmologists think there are actually billions of universes. I argued with one of them about it and said, why on earth do you want billions of universes? And he said, that way we can get rid of God. So I said, but at a very high price. I mean, isn't this the ultimate violation of Occam's razor, that you shall not proliferate entities unnecessarily? To which he replied, well, I agree it's a bit of a problem. We're working on it. So with habits that evolve, we don't need this kind of quasi-theological speculation about billions of unobserved universes, which is all too common in contemporary cosmology. So I think the habit view is more scientific, more testable, and more in accordance with an evolutionary cosmos.
Okay, well, I am not a closet Platonist. I am a Platonist. On the other hand, I don't believe that by discovering laws of nature we're getting an insight into the mind of God. I think that that's an entirely separate issue. So we were asked to debate three questions. So the first one was, do the laws of nature exist? If I'm allowed to remove the word "the," I will say yes. Okay, there are laws of nature. Okay, but the laws of nature, that sounds sort of somewhat closed, and I'm not sure that I'm going to go quite that far. Why do we believe the laws of nature are fixed and unchanging? Well, because they are, right? I mean, we look at stars, we look at atomic emission lines from stars that emitted those pieces of light maybe 10 billion years ago, and the frequencies are exactly the same as what we measure here in the laboratory. Those things are not evolving. Now, that said, of course, there are cosmological theories according to which the laws of nature might change. Dirac, of course, was a big advocate of this, but I think that those sort of ideas that he developed don't seem to hold water. It is true that there are these ideas that Rupert just mentioned, according to which there are perhaps other universes that we can't see where the laws of nature might be different. Personally, I'm not terribly interested in those speculations because I don't know how to test them. If I knew how to test them, then I'd have get a lot more interested in them. The third question that we were asked to talk about, can we reach a deeper understanding without eternal laws of nature? I'm not very happy with the word understanding. And I always say when this sort of metaphysical question comes up that we scientists, we physicists in particular, do with the who, where, what, when and how questions, but not the why questions. And for me, understanding requires some answer to why. And as I said earlier on, I don't get into the mind of God.
I find it hard to engage with the exact terms of the debate because I don't have anything like the image of the laws of physics that the other two have. So I don't think that physics is queen of all she surveys, and I don't think that the laws of physics hold everywhere or every when, or that they're evolving and still holding everywhere. So we're told that the laws of physics hold everywhere and every when. That's a tall order. I think that we have far firmer evidence for the claim that the laws of physics hold in special, constrained, structured situations where only physics matters. The trajectory of a billiard ball can be predicted using Newton's equations, but only so long as I haven't hired a slightly nervous, slightly incompetent marksman to sneak a gun into the hall and blow the billiard ball to smithereens in mid-trajectory. Okay. Well, I'm told that my condition is really no condition. I say laws of physics hold so long as only physics matters, and I'm told, well, that's no condition because only physics matters everywhere. That means, though, that how nervous this marksman is, how competent he is, and how good the building security is, that they let the gun in, is all a matter of physics, and I'll believe that when I see it. Now the other thing is the physics and the laws of physics. What work do they do? Well, I want to think about the work they do when I actually have to do some work in interface with the real world, as in manipulating or helping us understand the world. And there I think they make very small contribution, even where their contribution is essential. So think about quantum physics, which is absolutely essential, I think, to building a laser or understanding superconductivity. But the quantum physics by itself doesn't get you anywhere. It's more or less, in this enterprise, the ideas man. It does very little of the heavy lifting. Right? That's because both lasers and superconductors are not these nice situations where only physics matters. Right? They're just like the billiard ball with my possible competent or incompetent marksman. And to understand superconductivity or to build a laser, you need to bring in many, many other subdisciplines in physics, lots of engineering, lots of hands-on knowledge of materials, and to tinker. And without that team, you don't understand what's going on in superconductivity, nor do you get the design of the laser. So is physics queen of everything she surveys? And what about her edicts? Well, she may be, right? And she may be issuing edicts, but if she is, it's a bit like our queen sitting at the breakfast table looking at her broken toaster and saying, "Work, toaster." Her edict is not going to cut much ice in the real world without the considerable effort and cooperation of a pretty big team of those who are thought to be her subordinates.
The debate. Theme 1.
Okay, well, we're going to go through the debate, starting with the first theme of whether the laws of nature exist. And Nancy, let me pick up with something, your billiard ball example, straight off on that. You talked about the billiard ball, you talked about this marksman being let into the building. It might be the case that physics doesn't help you understand how the man got into or woman got into the building to shoot this billiard ball, or whether there's a direction that the billiard ball goes in, but the laws of physics as we understand them are still operating. Now, it might not help you in predicting what's happening there, but it does operate.
It depends on sort of how you read the laws of physics. Now, I think there's no doubt about the fact that I'm a massive object subject to the pull of gravity. Okay. Now, whether or not the pull of gravity can always be put into a model that has only other physics causes in it, so that a law of physics can dictate what I'm going to do. That's the issue. So there's a sense in which things we learn in physics will almost always be playing a role, but whether or not there's a kind of law of physics that tells you what happens when they're playing that role and lots of other things are playing their roles, that's what I think is problematic. So it's that the laws of physics aren't telling you what happens when there's more than physics going on.
Sure, and then the title of the debate is Laws of Nature.
Yes.
So it's many laws and of all nature. So we'll have it, you want to define these things.
So, but we don't, where would the laws be that tell you what happens when you've got sociological causes, psychological causes, and physics causes? That's more piecemeal.
But so John, then, in that case, you modified this particular bit of it slightly. Do laws of nature exist? And you said yes, they do. In Nancy's example, it's clear that it's partly there to explain bits of what's happening, but you would probably agree that it's not there to explain everything.
Yeah.
What are the limitations in the kinds of laws you're talking about?
Yeah, so I probably have to take the blame for this whole debate. Because I'm told that I coined the term theory of everything.
Did you? That's what it says here.
Yeah, that's what it says there. I don't actually think I did. Actually, it was a journalist who came up with it. But I was probably the person who was responsible for propagandizing it, because I wrote an article about string theory in 1986. And already at that stage, I introduced a doubt into the question. I wrote string theory, theory of everything or of nothing, question mark.
So they missed out the last two words.
Right. And the point that I was trying to get at, and which I would say again, is that, there are laws of nature that hold in idealized circumstances. But I think, as Nancy correctly points out, in a realistic situation, there are other things that come into play. It's not the idealized situation. And it's certainly true that we cannot, with string theory, calculate, Nancy's behavior on any given day. I don't think we would ever wish to, right? On the other hand,
I think you'd be better off if we did.
On the other hand, there are some aspects of Nancy's behavior that we can predict with, I think, great reliability. I think we can predict that if she goes up in an airplane and jumps out the window, she will fall to the ground, okay? And I think that to say that the laws of physics make a small contribution is crap.
Sorry. I disagree.
Oh, good, we can carry on.
Please explain.
I'm not too sure what she meant by saying that the laws of physics make a small contribution. I mean, quantum physics, for example, there was some economic survey a few years ago that argued that something like 1/3 of the American GDP was based on quantum physics. And it's certainly true that the LHC would not operate if superconductivity did not work the way that our laws of physics tell us that it should work. So in summary, I don't want to say that physics is queen. Okay, I think that physics is able to address a certain limited set of questions, as I said in my general introduction: what, when, where, how type questions, but not why type questions.
Rupert, you said in your opening statement about how you prefer the idea of habits rather than laws. Do you think that they are things that are in addition to laws, or are they the same thing? Is there a spectrum somehow? Or do you replace one with the other?
I think many regularities of nature, if not all, are habitual. And John's example of the spectral lines of hydrogen, you see, I would say doesn't prove there's a law. I would say that the habits of hydrogen were laid down very early in the history of the universe. And once habits get into a deep groove of habit, they become almost changeless. Like the limiting case of a habit is it becomes almost mechanical. Where you notice the difference is when you're looking at new phenomena, which is why I took the example of new chemicals being crystallized. In the case of the things physicists look at, namely distant stars and galaxies, when we're talking of astrophysics, they're looking at things that have been around for a very long time, and they're looking at things that have some of the most basic habits of nature, the habits of atoms and molecules and stars. And these and the habits of quantum physics, I think, have become so well established they behave as if they're governed by laws. And so I'd agree with John that these things are useful and they can make predictions in certain idealized situations. But the fact that they're useful, the fact we can use them to predict things, doesn't prove they're eternal laws. It only proves that they're well-established habits, in my view. And to distinguish between these two views, we have to look at new phenomena. And, for example, I would predict that in the realm of low-temperature physics, if you took, look at the behavior of atoms at, say, 0.1 degree above absolute zero. If the background temperature of the universe is 2.7 degrees Kelvin above absolute zero, many phenomena of low-temperature physics would be new in the history of the universe when they're carried out in a physics lab. And therefore, the first time you do it, the second time you do it, the third time you do it, you might observe an increase in the rate or difference in the properties of the system that you wouldn't get under fixed laws of nature. So it's a testable hypothesis. It's not a metaphysical idea, it's a testable hypothesis. And since we're told by some philosophers of science we should try and refute theories, it's a very good way of trying to refute the eternal laws of nature theory rather than assuming that it must be true.
You mentioned something about the was it the melting points of crystals?
Yes.
The rising melting points of crystals. Can you just tell us a bit more about that?
Well, this is probably a controversial claim because I'm almost the only person who's done research on the history of melting points. Because normally people assume that melting points are constant. You look them up in big lab handbooks called Handbook of Physical Constants. And most people assume they're constant because it says so on the cover. And we're all brought up to believe these are constants of nature. If you actually look, a chemist in Canada did this survey for me about 2 or 3 years ago. He surveyed, I think, about 1,000 different chemicals synthesized for the first time in the 20th century and looked at the first reported melting points compared with the latest reporting ones. And something like 95% of these chemicals, the melting points had gone up by 5 degrees, 10 degrees, 15, 20 degrees centigrade. We're talking big changes. Now, when I discuss this with chemists, they say, first of all, they're surprised because they don't, nobody's ever published papers showing, there are these rising melting points. But they think a moment and then they say, oh, well, there's a simple explanation. I say, what is it? And they say, well, impurities lower the melting point. As time goes on, chemists get better at making the compounds. Therefore, the later samples are purer and therefore have higher melting points. I said, well, how can you be sure they're purer? And they say, well, because they've got higher melting points. And it's not an unreasonable argument, but it could be tested much more rigorously. So far, it hasn't been. My point isn't that I'm right. My point is that it's an open question.
Okay. And just before we move on to the next theme then, I just want to, John, you're perhaps the more small c conservative in terms of the debate.
Definitely a small
small c. That's why I'm being very careful. Just, I'll let you have the last word in this particular theme and we'll move on. I mean, there's some big claims being made here about the laws of nature, and I wonder if it's about a vocabulary. Are Rupert's habits just evolved laws? Are they the same thing in your mind, or have the laws of quantum mechanics existed from the moment of the Big Bang and then they're the same now?
Yes.
No habits for you?
No habits for me, I'm afraid. And I hate to say it about my chemist friends, but probably I'm going to side with them on the response that they gave to Rupert.
I want to come right back now. Something.
So
I see. Simple, but why bother to think?
Rupert is making really extraordinary claims. Extraordinary claims require extraordinary levels of proof. And I just would like to see those extraordinary levels
from a distance.
Well, can I just reply to that? I'm not making extraordinary claims. I'm putting forward a hypothesis which I'm trying to test. And you see, if you have the idea, you can't say anything that people don't already agree with because it's an extraordinary claim. We'll set the bar really high because it's a claim that hasn't been proved. Hypothesis making and testing in science would grind to a halt, including your own hypotheses. It's an extraordinary claim that the laws of nature are fixed, that the Big Bang existed according to laws. Where's your evidence? You see, you think that's a normal claim. I think it's an extraordinary claim.
Theme 2.
So why do we think? What do we know about the development of science in the last few centuries that shows us that these laws, say quantum mechanics, whatever else, haven't changed?
So let me develop a point that I made earlier on, right? So, of course, physicists would be absolutely delighted to hear that what they think of as being unchanging laws of physics do change. And Paul Dirac formulated the idea that, in fact, the laws of physics do change over cosmological time. And just to remind people, the age of the universe is order of magnitude 10 to the 10 years. And so you might look over a period of, say, 1 year to see whether things change by 1 part in 10 to the 10. Actually, what people have done is that they have checked various physical processes, e.g., I mentioned this question of atomic spectra of very distant stars. And they've got upper limits on the time variation of some of these fundamental laws at the level of 1 part in 10 to the 14. Right? So I think there's very strong supporting evidence for the claim that at least some laws of nature do not change. Right? Now, I would hasten to say that I don't say that necessarily the laws of physics have not changed in the past in a rather narrow sense, which I don't actually think makes contact with what Paul is saying. We know that as you heat things up, then they tend to melt or become gases. And we know that we're currently in a state where there is this field throughout the universe called the Higgs field. Okay. And we think that if you go back sufficiently early in time, then that field, like a field of snow, would have melted, and that would have meant that particles did not have a mass in the sense that we currently understand. And so that would be an example of a law of physics which would indeed have evolved, right? Although not in something that, for the moment, we know how to test experimentally. And you could sort of subsume it with within some sort of meta-law.
So we can't right now rule out the fact that some of the laws would have changed at some point in the history of the universe.
Right, but we do have a framework for thinking about how that could happen.
Okay.
Which doesn't include habits.
Okay. Nancy, then, there is an overwhelming consensus amongst practicing scientists and that laws are... The laws of nature, as we've discovered them, are fixed. And our understanding of them might change over time. So our understanding of gravity has changed since Newton, but gravity, whatever that law is, that Platonic law, it is there somewhere. What does this say about our ways of understanding the world?
I'm sorry.
What is the fact that we need these laws to be the same, or the stable? The fact that scientists think this is the way that we do it. How do you think that tells us? What do you think that tells us about our attempts to understand the universe? Or
Look, John talks about evidence that certain powers or certain principles, certain laws in physics are stable. Okay? There are lots of laws in biology that almost certainly have emerged because they describe things that used not to exist. And unless you think that physics had it all fixed about how somebody, if not physics, something else had it all fixed about exactly how they would behave and what their biological and physiological and DNA properties would all be before they came to exist, there are new laws that come into existence as things change. Now, whether a particular law changes or not, I don't see that we human beings are so wedded to that idea. I do think that we have inherited, at least from the scientific revolution or from Platonism, an image of a certain image of the mathematical laws, certain mathematical laws of physics, that since we don't understand where they came from, we rather like to think of them as eternal. But I don't think that it can't be a matter of how humans understand things, since we're perfectly happy to understand that there are new laws in biology, and I think new laws in social science all the time. I think there are new arrangements. We keep talking about physics all the time, but social science is really a genuine subject, and we create new situations and new cultures and new social structures all the time, and in those social structures, new regular, systematic, predictable, reliable forms of behavior come to be the case. And that seems to me like it's a new law, and the laws change as the social structures change. So it does seem to me that some of our laws change. We have reason to think some of our laws change. We have reason to think some of them don't, and we're not, as human reasoners, wedded to one view or the other.
Well, let's move on to biology. This is more your subject,
Yes.
Rupert. With biology, things are much messier. We don't know really how many of the processes in cells physically work, but then we don't need to know that. We know that something happens and then we get a result out of it, and we test and test and test, and most times this happens and a few times something else happens. Where's the law in that? There is no law.
Well, no, there are quite predictable things about biology. I mean, they're mainly statistical. I mean, Mendelian genetics is a statistical science. Population genetics is a statistical branch of speculation. But I worked for years in developmental biology. If you're trying to understand how organisms, in the case that I looked at, plants, develop from fertilized eggs, then there are certain regular things you can describe in that process. There are certain interferences you can impose, and you get fairly predictable results. So it's not as if this is an area of complete chaos and disorder. It isn't. Biology wouldn't be possible as a science if it
Even
were.
chaos is predictable to some extent.
That would be in the mathematical sense. I mean, when it comes to the understanding of inheritance in biology, that's why I got interested in habits. I think a lot of inheritance works not through DNA molecules programming the development of an organism. They program the development of proteins. But I think inheritance depends to a large degree on a habit principle, and so does memory, our psychological memory. The assumption it's all encoded in the brain in molecules or modified synapses is an essential part of a materialist mechanist view of the world, which doesn't have a memory principle within it. Memory, therefore, becomes a matter of material memory traces. And it's a very debatable point as to whether they exist. The evidence on the whole suggests they don't. Most scientists assume they must. So these are all areas where empirical research can actually shed a lot of light on the subject. And once you get into these areas, the behavior of atoms of hydrogen in distant galaxies doesn't seem terribly relevant. I mean, that's very relevant to physics, but in biology, most of these questions are debated without much physics or even without much maths.
John, just a final word for you on this theme then, about whether laws are fixed and unchanging. You've been quite categorical in saying, yes, there's probably potential that at some point very early on in the universe, the Higgs field, for example, might have been different, but we know that hasn't changed, in our experience at least.
Hasn't changed recently.
No, it hasn't changed recently. But if I can just get you to imagine this. If you did at CERN or wherever else find that some relationship between two of the laws, some constant has changed in some point, and it's different, how big a deal would that be? And if you've proved it as well, how big a deal would it be?
It would be a fantastically big deal, right? It would be a fantastically big deal. I won't say it would, consign the Higgs boson to a footnote of history, but
Not suggesting about the Higgs boson, just anything. If you found anything, the electron charge changes or something, whatever.
Yeah, well, in fact, that's actually what some astronomers have been trying to look for, and precisely, the community, holds them to very high standards of proof, and I'm afraid that so far they haven't, met those standards of proof. But I think that the physics community as a whole would be delighted if it turned out that they were right, because precisely, I think physicists in particular, but scientists in general, I think are contrarians, right? We don't want convention to hold. We want something new to be discovered. We want to see things in a different way, because it's only by doing that you get to a deeper level of comprehension of the universe. So it's not that we're trying to sort of suppress people who claim that the constants of nature are varying. We would be delighted if they could demonstrate that they were varying.
Can I follow up on that with a question, a knock-on question? I mean, it would be exciting, and presumably not resisted, except expected to have a high level of proof. But what would be if there were? It seems to me that for most constants, if they were to shift, that would have considerable knock-on effects, not just in our understanding of physics, but that would have considerable knock-on effects in how the world is organized, since the
matter could fall apart, for example.
Yeah, well,
and so I was wondered, is that not an issue as well?
Yeah, well, the point has been made that if the fundamental constants of nature were even ever so slightly different, then life would be impossible. There would be no deuterium.
We'd have other problems, I think,
yeah.
if that would happen.
But perhaps I could just throw another little stone in this particular pond, which is, I said we've got a particular value for the Higgs field at the moment, which gives particular masses, for example, to the electron, and that enables atoms to exist of a certain size and so on. But the recent discovery of the Higgs boson at the LHC opens up the possibility that, in fact, at some point in the future, our vacuum will collapse and we will go off into an entirely different state of the universe. So the point that you're making is an extremely important one. It could very well be that, things will change drastically.
Theme 3.
Nancy, let me ask you to pick up on something that John said. John said that scientists like to be contrary; they're contrarians. Do you agree?
Well, there's no such thing as scientists. There are.
Well, here's one.
There are millions, yeah, but the scientist is not a normal. There's not the normal scientist, the average scientist, the normal scientist. Different scientists have totally different views as far as I've experienced. I always find it very strange when I'm told physicists believe in the eternal laws of nature, and then I talk to physicists and some haven't even thought about it, right? Whether the laws of nature are eternal, what a law of nature is, and so forth. Some scientists are contrarian, some aren't. Some like big changes, some like little changes, some require high levels of evidence, some require low levels, some require certain kinds of statistical evidence, some want the golden event. I think that it's a wonderful thing. Science works by, in large part, by the fact that scientists do have slightly different attitudes and demands, and an awful lot of demands have to be met simultaneously before something becomes accepted in the scientific community.
Okay, then, let's go back to the laws then, as we've been discussing them. If these things don't exist, or they're changing, or whatever else, can we still reach a very deep understanding of nature without them?
Yes. I mean, what's a deep understanding? Of course, you can come to understand what there is about nature to be understood. And if it's a changing law and you recognize and can represent that it's changing, you've got a good understanding. If it turns out that the laws are constrained in their domain of governance, as I think they are, they're more like habits or powers that have to cooperate with other ones, you can understand what happens in a situation. We perfectly well understand what happens when the billiard ball is smashed to smithereens. And it doesn't require...
Or when we drop you out of an airplane.
I don't think you've seen How to Train Your Dragon, right? he's dropped and gets caught all the time, and that's what's going to happen to me when I come out of the airplane. And I know that because I'm a good
Let's do the experiment.
I keep my dragons in the basement.
It might be a
cool.
statistical thing. Rupert, you've talked about habits. Does that mean for you, we abandon the laws and go in this other direction, and does that allow us to get a richer understanding of what nature's doing?
Well, I think we can go on using the word law if we want to, but if we see it's a kind of limiting case of habit, long-established habits behave as if governed by laws, as I said. But I think if we live in a radically evolutionary cosmos, then the principles that govern it may be radically evolutionary as well. And I think that within the sciences, we do have this long tradition of Platonism among mathematicians and theoretical physicists, and Platonism is radically non-evolutionary.
And theoretical economists.
Oh, yes. Anyone who's been imbued with mathematics, it's really Pythagoreanism. And it's a metaphysical view of reality, and it's even a theological view of reality. And people are perfectly entitled to have it. I'm not a Platonist or a Pythagorean myself. And I don't think it need have a specially privileged position in science just because a lot of physicists have thought that way for a long time. And I think what we have is, since 1966, when the Big Bang theory became orthodox, we've had this radically evolutionary cosmology. That changes a lot in science, even physics. And I think that in a radically evolutionary world, then having a radically evolutionary understanding is more in accordance with the way things are than a non-evolutionary perspective. So I think we'd have a better and a deeper kind of science. And I think we'd also be able to understand phenomena like inheritance and memory much better if we move on to this view. And finally, the idea in the West that there's a kind of Platonic eternal reality is very deep-seated. I mean, it dates back to Pythagoras and Plato. However, in India and in Buddhist cultures, they have a completely different cosmology. When I first came up with the idea of habits of nature and morphic resonance, I was a don at Cambridge, and I was met among my scientific colleagues with blank incomprehension. When I then had a job in India working in an international agricultural institute, and when I discussed it with my Indian scientific colleagues, I got a completely different response. They said, "Oh, there is nothing new in this idea. Ancient rishis have said this thousands of years ago. The idea of habits in nature is completely inherent in Oriental philosophies, where there's a kind of memory principle." So it's not as if this is the only cultural norm that we can conform to. There are quite different ones. And I think that this view would actually raise all sorts of new philosophical positions which have been explored more thoroughly in Oriental philosophies than in Western ones.
John, can science operate without these laws? It's a sort of follow-up to our earlier question, but can they?
Well, I think we should maybe step back a little bit and ask ourselves, what exactly do we mean by laws? I mean, what we're trying to come up with is, rules of the game that seem to work, right? And I think that we should, all of us, even physicists, be humble enough to admit that these descriptions are provisional, and that they are subject to new data coming along which could blow them out of the water. And as I said, physicists generally are very happy if some even extremely successful theory gets blown out of the water by some new idea or some new measurement. The classic example, of course, is Newtonian gravity. We were delighted. I mean, perhaps I shouldn't say
but
we.
Newton wasn't.
I would have been delighted to hear that Einstein had come up with a better theory of gravity that explained phenomena that we couldn't understand with Newtonian gravity. Anyway, I think we really, like I said, we should interpret this phrase "law of nature" as a provisional description which is subject to change. But, like I said, these basic laws of physics that I've been talking about, I don't see any evidence that they do change. And I, in fact, see a lot of evidence that they don't change. And as I said, people have been looking very, very hard to see ways in which they might have been changing. But I'm not going to venture into the fields of biology and sociology, right?
It's too messy.
Well, I don't know whether it's messy or not. It's just something which I have no expertise, and I prefer to stick within my own little narrow area of expertise.
Thank you for listening to this Institute of Art and Ideas podcast. If you enjoyed this debate and want to carry on the discussion, visit iai.tv. Remember to subscribe and review on iTunes.